So hey guys, how are you? So today we're going to discuss the differentiation. So in the previous lecture we have discussed the great detail of limits. So I hope you enjoyed this lecture. So if as then please like our video. So it motivates me to do the great videos, okay? So I just want to discuss the differentiation. In a previous introduction lecture I have given a great introduction to the differentiation. So I just want to recapitulate what I have said there. So the differentiation calculus is a mathematics of change. So mathematics of change means what? How much this changes when that changes, how much x changes when y changes, right? So these are related, means x and y are related if this changes and this also changes, right? So it's just a process of finding the derivative of a function. So what is the derivative? So it is used for the finding the slope of the function by using the derivative. Okay, so it is a process of finding the derivative of function like x is equal to y square. So the derivative is just a fancy word. It's the idea of to form a algebra, that is slope, right? As a previous, so it's just a find of a we just find the slope of the function by using the differentiation. Okay, so we have a triangle over here, we have a hypotenuse over here, and we have a rise and run over here. So we have a triangle over here. So this hypothesis which is slope of our function. In English we called it as a steepness, and in algebra we call it as a slope, and in calculus we call it as a derivative, which is dy by dx. Okay, so we just want to find the derivative of this function. So what is the formula? Rise over run. We simply rise over 1. We simply use this formula and we're going to get 1 by 2 by 1, 1 by 2 by 1, which is 1 by 2. If we have a coordinates, then we're gonna use like y2 minus y1 by x2 minus x1, right? So if we have a coordinate, then we use this. Otherwise we just simply rise over run, right? So the derivative of this function, which is g of x, and the value is 1 by 2, right? So the value is 1 by 2. So the derivative is just simply the measure of how much y changes when x changes. So we have a dy by dx, right? So we have a dy by dx. The y, how much y changes when x changes? How much y changes? I have given a previous example, like a better example, right? So the 1 liter of petrol and a bike and a range of the kilometers, which the range of the mileage. So how much the petrol changes when the kilometers changes? So if it is 2 liters, and it will become 100 kilometers, right? So these are dependent. These dependent on the input variables, right? The differentiation is used in a back propagation in the field of a machine learning and a artificial intelligence, right? So it is used in a back propagation. So what is back propagation? We're going to discuss in our machine learning lectures. So how it is useful in our models, etc. So don't worry. So as of now, just leave it. Okay, in various formats we can write the derivative. So we have a lot of formats, like we have a lot of formats to write the derivative of a function. We use dy by dx, or we use d of f of x by dx, right? Or we use a f prime x or y prime, or d suffix x f. So these are the ways which we write the derivative of a function. So I just want to give, so I just, as I said, so what is the, so I just want to recapitulate it. What is the differentiation? So to find the derivative of a curve, it is called as a differentiation, right? So it is used to find the derivative of a curve, which is the slope, to find the slope of the curve. So we just find the slope of this curve by using the formula over here, which is the 1.2 is the slope of that curve. So and we have a lot of ways here. So how we find that? So after that we have a, so I just want to give a real life example. So Tarak, which is me, is 50 kgs, okay, and Sai, which is my friend, which he is a 30 kgs. He's not in 30 kgs, he might be like a 60s or 70, but so as of now, so I just want to better than the Sai. So I have written this, okay. So Tarak is 50 kgs and we have a Sai is 30 kgs, okay. So if you remember in our childhood, we used to play this game, right? So if it goes down, it will goes up, and if it is go down, it will go up, okay. So the Tarak is sitting over here and the Sai is sitting over here. So if the Tarak, which is he is 50 kgs, right? I just want to write it so it will be easy for you. So he is 50 kgs and Sai is 30 kgs, right? So if Tarak is 50 kgs, then he is 30 kgs. Means like, so as of now, I just want to, so just take it as a 60 kgs, okay? Just take it as a 60 kgs, so it will be easy to determine in a numerical way. So if I am a 60 kgs, so I'm a 60 kgs, okay? I'm 60 kgs and Sai is 30 kgs. So I'm 2x, means I am double of the Sai's weight, okay? So if I down here, if I apply force here and down here, then the Sai will go up twice. If I put 10 kgs down, if I put 10 kgs pressure here, and the Sai will go up 20 kgs, right? I hope you're getting here. So for every inch the Tarak goes down, the Sai goes up in twice inches. Means like the Sai moves twice as much as Tarak. Are you getting it? The Sai moves twice as much as Tarak. Means like the derivative of a Sai with respect to the derivative of Tarak, which is 2, means like the Sai which is 2x faster than the Tarak. So the Sai movement, which is 2 inches per 2 inches more than the Tarak's movement. So from the Tarak point of view, right? So the change in the Tarak with respect to the change in the Sai, which is equal to the half. Means like if I so the derivative, so the change in the Tarak is equal to the half of the change in the ds. I hope you're getting it. So like if I move 50 meters, then the Tarak moves only, which is 25 meters, right? I hope you're getting it. So the Tarak movement is 1/2 inch for the Sai's movement. I hope you're getting it. So I just want to clearly explain once again. So like Tarak, which is 50 kgs, and the Sai, which is 30 kgs, okay? So 60 kgs and we have 30 kgs. So the Tarak, which is twice as much as the Sai, okay? So if the movement comes from the Tarak, it will be the twice more from the Sai. So if I move 10 meters, and the Sai will move like 20 meters, and if Sai moves 10 meters, I only move 5 meters. So I have given a clear example, like, so that you can understand it very well. I hope you understand. It's just a simple example to find the derivative in our real life example. So I just want to find the derivative of a curve. How we find the derivative of a curve? So where the slope are constantly changing at every point. So we have seen our tower examples, right? So we have a tower examples, right, in our calculus problem where the slopes are constantly changing. So how we find it? We just simply infinitely zoom, right, etc., right? So just preview that lecture. We have a function which is y is equal to 1 by 4x square. This is our function. How we plot that? The function in the line. Please preview the lectures. Where I plot the equation line. Okay. So we just find the derivative of that curve. And we will get our answer is 1. So we take slope exactly at that point. So we just simply take the slope at that point. So whatever it may be the point, but we take the slope of that at point. So how we find the derivative of the curve? We just simply plot our values. And we just simply find the derivative of that, and we will get our output. And this point we take the slope from that point. Okay, I hope you understand this. We have a difference coefficient. So what is difference coefficient? Okay, so if the line, which is the secant line, so what is the secant line? So it is the line which intersect at a 2 point. So I just want to give 2 coordinates. Okay, so it will be like, so there are 2 coordinates here. Which is x comma f of x. If it is x and the length is h, and it will become x plus h, right? It's just a common example. Okay, so this will become the x plus h and f of x plus h. We are having x plus h here, so it will become x plus h. If you have x here, right, so it will become x. Okay, I hope you understand. So if you have 2 points, and the line which we are drawing, the line of a function which we are drawing, if it intersects at 2 points, here it is intersecting at so if you plot these values, if I plot this function, it is not intersecting at, right? So it is not intersecting, but it is intersecting at 2 points. So then we call it as a secant line. then we call it as a secant line. How we find the slope of this function? We have a formula, right? If we have a coordinate like y2 minus y1 by x2 minus x1, we just simply find our slope. It's just a kind of easy thing, but as of now, just leave it how we find this. So it is a big equation to find the derivative I just explained here, so don't worry. Means like if you take the x plus h and the f of x plus 1, put you slide this point, it means like if you are sliding this point to help the find the secant line. So the parabola is like this, but you are sliding this point, means like you're sliding this point to find the secant line. Okay, this is the secant line, right? So to find the secant line, the point comes down to the here. What is this? X comma f of x. I hope you're getting it. So this is a chance of a forming of a secant line. I hope you're getting it. So there might be a chance of a tangent line. So what is the tangent line? So this is a tangent line. So at some point, the time both intercept on a curve line, and a tangent is formed. So this is a tangent line and this is a secant line. This point, which are intersecting these 2 points. So the slope of the tangent line is the derivative of the function. So we just find our derivative function, which is y2 minus y1 by x2 minus x1. So the secant line, the point. So the equation from here. So what is the equation here? This is the equation. These are the coordinates, right? These are the coordinates, means like these coordinates are sliding. Oh, what the heck. So these are the coordinates are sliding down here to come the f of x plus h of x function. I hope you're getting it. So these are sliding down to come here to form a secant line and a tangent line, right? So if I give a form an example for this, so if we have a function right here which is limit x is equal to 0, this is the formula here. This is the formula if the limit exists. This is the formula of a derivative of a function if limit exists. So how this formula came? Yes, how this formula came? So if you look at these coordinates which we have these two, we just simply plug in these values. So we simply plug in this y2 minus y1 by x2 minus x1. So we just simply plug in these values y2 minus y1 by x2 minus x1. So we just simply plug these values and x got cancelled, and our equations like f of x by h, right? So this is the difference coefficient, right? So when the limit x is equal to 0, then it will become a tangent line. I hope you're getting it. So I just want to find the derivative. So I just want to find the derivative of that function. So I just want to find the derivative of a function. Okay, it will become like 1 by 4. So I'm just multiplying with this, which is a square plus b square plus 2ab, right? This is square. I'm so sorry. This is square. Okay, I'm just multiplying with these, and this is 1 by 4x square by h, right? So it will become right what? If we multiply these two, and we get our 2xh plus h square by 4 by h, and it will become, if we take the x common, and it will become 4 by h, and we just simply cross out the h value here, and it will become like 2x plus h by 4. Here the h is 0, right? So if h is 0, and then it will become 2x by 4, it will become like x by 2, right? So we can write it as a 1 by 2x also. This is our derivative of this function. This is our derivative of this function. I hope you're getting it. So how we find the derivative? Simply written this from the equation, right? And we have if we calculate these two, and we will get our output. So just leave it the calculation. We can do in our computers. We will do in our computers. Don't worry about the calculation how this came up. But do understand like what's going on here. So I just want to recapitulate what I have said until now. I have started with the differentiation. So what is differentiation? It's just a finding the slope of the curve, right? That derivative is just a fancy word term, right? So it's just finding the slope of that curve. So what is the differentiation? It's just finding the slope of that curve. So I have given the how we find the slope of the curve by using this diagram. Okay, so we just find the slope of the curve by using the formula rise or run, and if we have coordinates, then it will become y2 minus y1 by x2 minus x1. Okay, so and we simply, I have given a practical example like how these gonna relate in our differentiation lectures. Okay, how these gonna like how these gonna relate like dy by ds by dt is equal to 2 and ds is equal to 2 dt, or dt is equal to 1 by 2 ds. I hope you get the basic understanding what is the differentiation, and I also discussed how what the derivative of the curve, how we find the derivative of that curve by using the equation, and I have discussed the difference coefficient. So what is difference coefficient, and how we find the secant line, how we form the secant line, and how we form the tangent line, and how we find the difference coefficient, right? How we find the different coefficient, and we have a different coefficient derivative of the formula, how we find the derivative of this equation, right? How we find the derivation. So I hope you understand until now. So in our next lectures we have a, I want to discuss the differentiation rule. So we have a multiple over here, so we have a 12 rules over here. I have explained in a great detailed way. So these 12 rules, I hope you enjoy this lecture. So until then, bye bye, see you in the next lecture. Okay, bye bye.